Welcome. In this video, I'll be talking about understanding limits in calculus. Limits are a fundamental concept in calculus, serving as the foundation for defining derivatives and integrals. So it is the foundation for defining derivatives and integrals. Understanding limits is crucial for delving deeper into calculus and exploring the behavior of functions as they approach specific points or infinities. So they are used to explore the behavior of functions as they approach specific points or infinity. So what is a limit? A limit describes the value that a function or sequence approaches as the input or index approaches some value. So it describes the value of a function or sequence as the input x approaches some value. In more formal terms, if we say that the limit of f of x approaches as x approaches c is L, we write this as follows. So we can write it as something as limit as x approaches some value c of f of x is equal to the limit. This means that as x gets arbitrarily close to c, f of x gets arbitrarily close to L. So now I'm going to give you the formal definition. Or of how to interpret the limit. Formal definition. The formal epsilon-delta definition. We say that the limit of f of x as x approaches c is L if for every number epsilon greater than 0 there exists a number delta greater than 0 such that whenever the absolute value of the difference between x and c is greater than 0 and less than delta, it follows that the difference of the function value at x minus the limit is less than epsilon. So now I'm going to give you 3 examples to see how the definition works. So example 1, we need to find limit as x approaches 3 of 2x. The way you do it is as follows. So the limit as x approaches 3 of 2x is equal to, this is a basic limit, so all you need to do is look at the behavior when x approaches 3 of the function. So we need to plug in 3 and we get 6. Now we need to do example number 2. We need to find the limit as x approaches 2 of the rational function of x squared minus 4 over x minus 2. The way you do this, so this would be a rational, so the way you do it is as follows. Because you have a rational function, you want to get rid of, because as x approaches 2, this is undefined because 2 minus 2 is 0, so x squared minus 4 over 2, that gives undefined. So we need to do something about this function to make it work. So we can say something like limit as x approaches 2, and we can factor x squared minus 4 as x minus 2, x plus 2 over x minus 2. And then we say for x not equal to 2, lim as x approaches 2 of x minus 2, x plus 2 over x minus 2. We can cancel this and this becomes limit as x approaches 2 of x plus 2. Now we can do a basic limit, so this would be equal to x plugging 2 into the function, that would be 2 plus 2, which is equal to 4. So the limit is 4 when x approaches 2 for the function, for the rational function. Now let's do the last problem, which is limits at infinity. One example for it. So we need to find the limit as x approaches infinity of the rational function 5x squared plus 3x plus 2 over 2x squared plus x plus 1. When dealing with limits at infinity, focus on the terms with the highest degree in the numerator and denominator. So here the highest degree would be this one and this one. So we can say that so focus on highest degree term on numerator and denominator. So limit as x approaches infinity of 5x squared over 2x squared is equal to limit as x approaches infinity. So this cancel, and this becomes 5 over 2. And the limit as x approaches infinity of 5 over 2 is 5 over 2. So what's the importance of limits? Limits are essential for defining continuity, derivatives, and integrals. They help us understand the behavior of functions near points of interest and are crucial for solving real-world problems in physics, engineering, and economics. Mastering limits is a stepping stone to advanced calculus topics. By practicing with different functions and scenarios, you can gain a deeper understanding of how functions behave and prepare yourself for more complex mathematical challenges. So they help us define continuity, derivatives, and integrals. Thank you for watching. Please subscribe.